Hi and welcome to this video about zombie processes. A zombie process is not a Windows official term, but I think it is very apt. So what is a zombie process anyway? A zombie process is a process that has terminated for whatever reason, but its management object, the eProcess data structure that manages a process in kernel space, cannot be destroyed. That's because it's still being referenced. In most cases, this is because there's at least one handle open to the process. That also prevents a process ID reuse, which means that you might notice on a system that process ID numbers start to get very high, relatively speaking, in the 100,000 or more. In most cases, this is because zombie processes plague the system. Let's see that using tools. So first, let's start with Task Manager. Here's Task Manager. Going to the Performance tab to the CPU area, we can see that there are currently 443 processes on my system. That sounds reasonable enough, at least for my system. But let me open a tool called Object Explorer. This is one of my tools you can download from one of my GitHub repositories. And one of its capabilities is showing the number of kernel objects of every type that exist on the system at any given point in time, and it is updating in real time. So you can see here that currently on my system there are 5,938 objects, although Task Manager claims there are only 443 process objects. So we have a big discrepancy here. Should be 5,000 something, so either one of these tools is lying or something else is at work here. In fact, both of them are telling the truth. The Task Manager view is only for processes that are alive in the sense that they can still execute code. They have at least one running thread, at least one thread that can do work. So these processes are alive. However, what Object Explorer shows is the total list of objects which are currently in memory, still alive from the kernel's perspective. So let's see what happens to the other set of processes that are not shown in Task Manager. These are exactly zombie processes. This tool also allows us to see that. So if I go ahead and use System Zombie Processes options here, we can see the list of all the zombie processes that currently exist on the system. They are no longer running, but they can't really die from a management perspective because they're being held by at least one handle. So here's an example process here, HP SUPD Win32EXE, some HP printer process being held by another process called HP Print Scan Doctor Service and yet another process called Game Manager Service. So we have two handles here holding on to this object, and that's why this object, this process object, cannot really die. And you can see its process ID, which can't be reused until further notice. So notice the process ID 72176. We can also check this using a kernel debugger. So I have a local kernel debugging session open here. Let me use process, and we need to provide decimal value here, which is 72176. 72176. Let's see what the debugger has to say. So it's looking for a process and it finds that kind of process, and notice there are no active threads. There is in fact one thread which is still in memory, but notice it has terminated, which means this is in fact a zombie thread. A thread that can no longer run any code, but still being held in memory because there's at least one handle or some reference holding on to this object, keeping it alive. Notice this process has no object table, meaning it has no handles. Also has no address space. The VAD root here points to some data structures managing the virtual address descriptors, which is a way to manage the address space of a process. There is no address space anymore. If I go ahead and grab the address here again and use the object command to get some general properties for the object, you can see there are two handles open to it. In fact, if I click that, the find handle command in the debugger will find those two handles, which already know where they actually are because we see them directly here using this tool. And so in fact you can see here that there's lots of handles being held by this annoying HP Print Scan Doctor Service something. And if you go further down, we might find other processes which are probably the culprits for holding on to so many processes being alive. The other one is this Game Manager Service process from Razor, which keeps handles open indefinitely. In fact, you can see it holds on to handles to so many processes that are really not running anymore, so there's no point in holding on to those handles. Notice it's the only one holding handles to many of these processes. So it would be perhaps a good idea to destroy this process, because when a process terminates, the kernel guarantees all handles used by the process will be closed, and so many of these process objects will finally be able to die, which means memory will be freed and their IDs could be reused. So again, notice right now we have 5,469 processes, zombie processes at this point. Let's go to the game manager service here and let's kill it forcefully. Notice it has 6,000 something handles, which is quite a lot for a relatively simple process here. Let me use end task here to terminate it. Now it's gone. Going back here and pressing the refresh button, you can see the number has improved dramatically. Only 635 zombie processes right now. You can also see that the number of process objects have been reduced dynamically and dramatically to 1,100 something objects, which is much less than the 5,000 something that we had previously. So these are zombie processes, and you can see they definitely exist, and for misbehaved applications or processes, they might keep other processes alive. You can see there are some more candidates here for early termination so that they won't hold to these processes being alive for no good reason. Again, that HP print scan doctor is definitely a good candidate. And by the way, because zombie threads exist as well, there's an option here to show zombie threads. These are all the thread objects which cannot run any more code, but they can die either because they have at least one open handle or reference keeping them alive. And again, you can destroy the appropriate process and then these handles will be closed and hopefully the thread object will be able to die. But I guess zombie processes are perhaps a bit more worrisome because process objects are significantly bigger than thread objects.